So in this video we're going to be calculating resultant forces. Now for that we're going to use a force diagram. There we go. Force 1, force 2 and force 3 all acting on a single object. Now let's come up with what those forces actually are. So there are my three forces. So this one is 4i minus 5j, 10i plus 2j going in that direction, and negative 6i plus 7j. Now I haven't drawn it to scale. Doesn't really matter. We don't need it to be drawn to scale here. So, we're going to be finding the resultant force. So the big question is this. If these three forces act on this object, what will be the resultant force? In which direction will this object be moving? And this is super straightforward. The resultant force on this object is equal to the sum of the forces acting on the object. So now we just need to add those forces together. So it's going to be really straightforward. It's going to be force 1 plus force 2 plus force 3. And we can say that that's 4i minus 5j plus 10i plus 2j plus, and you need to be a bit careful here, negative 6i plus 7j. Okay, 4i, 10i, negative 6i, that's 14 minus 6, that's 8i. Negative 5j plus 2j is negative 3j, plus 7j is 4j. Really, that's our answer. I should really come up with a resultant force here. Okay, our resultant force is equal to 8i plus 4j. I can now sort of draw that on my diagram somewhere. 8i, 8 across, 4. This isn't drawn to scale anyway, so I can't really draw it to scale. But it means that it's going to be moving across and across, so it's going to be moving like in this direction somehow. Okay, so that is a resultant force. We just add up the forces. Of course, you could be asked to find the magnitude of the resultant. You could be asked to go sort of how fast is it traveling, or how many newtons are being applied to, how much force is being applied to it. So in that case, you're just finding the magnitude of that vector. Now, given we've been talking about forces, we better just call this newtons, 4 root 5 newtons, which is about 8.94, something like that. You might also be asked a different question. Find the angle that R makes with the I component. That's the same as asking like the angle that it makes with the positive direction of the x-axis. So we're finding that angle there. And again, that shouldn't cause us too many issues. Tan theta equals 4 over 8. Theta equals the inverse of 4 over 8. Which means that the angle that it makes with the eye is 26.6 degrees. Now there is sort of one more way that we can take this question, and it looks a little something like this. Change force 1 so that the resultant is equal to 0. And that means that all of those forces are in equilibrium. And that idea is going to be really important for us moving forward. So it's pretty straightforward. The resultant is equal to the sum of the forces. So we want the resultant to be equal to 0. So 0 equals, and then we know force 2 is 10i plus 2j. We know that force 3 is negative 6i plus 7j. And what else do we know? We don't know force 1. But force 1 must be made up of an I component and a j component. So I'm going to call force 1 AI plus BJ. And so that, just to make clear, is force 1. Okay, so what can we do now? We kind of rearrange this and get it in terms of AI and BJ. I'm just going to do something naughty here and put my equal sign right in the middle. Imagine they're lining up. Okay, so 10i, I'm going to move to this side as negative 10i. Negative 6i, I'm going to move to this side as positive 6i. 2j, negative 2j. 7j, negative 7j, is equal to AI plus BJ. Okay, negative 10i plus 6i is negative 4i. And negative 2j minus 7j is negative 9j. And we're pretty much done here. So therefore, force 1 required for equilibrium should be negative 4i minus 9j. Alright, so the idea of a resultant is really important. It's the sum of the forces, and you can do little things with that if you want to, but the key idea is really up here. You've learnt that before. And equilibrium is going to be a really, really important idea. Everything we work with for the next week or so is going to be all about equilibrium.